Hello everyone and welcome to another session of MindMatrix. In this session we are going to discuss the GATE CS 2024 paper, and it was the afternoon paper they set to. We are going to discuss the theory of computation questions, introduction. I am Tathagata today. I secured all India rank 21 in GATE computer science, and right now I am pursuing my final year in MTech computer science from IIT Bombay. I am going to join Coupa Software as a data scientist. I have 1+ years of teaching experience and mentored more than 500 students. Moving ahead, courses are already available by any of them, and the best thing is we are offering placement preparation placement 2025. This is completely free for everyone. You can register it from our website. Anshul sir is teaching this course. You can see our unmatched quality content, why the faculty matters when you are preparing for such a journey. You can figure out from this one, and you can connect with us. This is our WhatsApp channel, our MindMatrix official Telegram group, and our web page. You can register in any of them. More than 2000 students are already in the Telegram group. They are asking their doubts, questions every day, and we are solving them. So start your preparation journey right now. Okay, so without further ado, let's start with the questions of this set. There are, I guess, 4 questions. Let's discuss the questions. Okay, yeah. The first question says, which one of the following regular expressions is equivalent to the language accepted by the DFA given below? All right, so let's see the DFA first. Yeah, a zero loop which is in state A, then state A goes to B with 1, state B has a zero loop, and state B goes to A with 1. Okay, there are 4 options. Now there is a trick, or I won't say trick, this is something you develop with more and more practice. Okay, so you know Arden's principle and those things, how you can derive regular expression from a automaton, from a DFA or NFA. So seeing that question, if you right now start delivering or start deriving the equations for the regular expression, that will take a long time. For sure, that will take a long time, and this is not the optimal way to solve a question in a competitive exam. This is the right way to build concepts, right way to learn, and that is important, because if you get stuck in a point, these building depth concepts will help you. But more and more practice gives you a hand advantage. Okay, what is that? Now, seeing this set of options, I can see some things, some things that I can notice already. Okay, let's talk about this option D. What I can see in here. So what does star means? What does A star means? A star means A to the power m, where m greater than equals to 0, right? So there can be no A or any number of A, right? Okay. So and what does equivalence mean? Equivalence, it says equivalence, right? So there is a regular expression R, there is a machine M. What does equivalence mean? Equivalence means that language generated from the regular expression equals to language generated from the machine. Okay, or I will say that R is equivalent to M if and only if for all W belongs to language of R, W is accepted by M. Did you get it? So R is equivalent to M if and only if. Both side equivalence mean this is true if this is true, this is true if this is true. Okay, for all W belongs to language of R. So all from the language generated from R, from this regular expression, all the strings that belongs to that language has to be accepted by M. Also the reverse is, all the strings accepted by M has to be generated from the regular expression. That is the both side equivalence. Okay, yeah. So let's generate a string. From 0 star I take nothing, from this whole star I take nothing, from this 0 I take 0. So a string is this, right? 0 is a string generated from this regular expression. Now run on the machine. 0 from A is a starting state, from A to A, 0, nothing changes, right? and A is not the final state. Final state is B. So is this string accepted by the machine? No, but it is generated from the regular expression, hence it is false. Okay. Okay, now coming to option B, I can cancel out these things very quickly. Option B, from 0 star I am taking nothing, from this whole star I am taking nothing, from 0 star I am taking nothing. So from all these things I am taking nothing. What is the string generated? Null string, epsilon, right? Is null string accepted here? Null string is basically in A. Is it accepted? No, it is not accepted. B is also false. Now for this one it is a bit tricky, because for example you can try, but you cannot generate a string from the regular expression that will not be accepted in the machine. You are checking that for contradiction, right? You cannot generate a string from the regular expression that will not be accepted by the machine. But the reverse, let's talk about this string. Let's run it on the machine first. Okay, so 1 it goes to B, 0 it is in B, 0 it is in B, 1 it is in A, 0 it is in A, 0 it is in A, 1 it is in B. So it is accepted by the machine, right? So this string, say it is W. Now W belongs to language of machine for sure. For equivalence, what do you have to check? If W belongs to language of R. Now 1, okay, so let's write it here, 0 star 1, 0 1 0 star 1 0 star. Okay, 1 first is 1, so we cannot use this 0 star. 1 has to come from here. Okay, now this part says 0 1 0 star 1, it's whole star. So there are 2 zeros consecutive to this. Can we generate 2 zeros? No. If we use this bracketed part, after the 0 1 has to come, and if we take at least one instance of this bracketed part, at least 0 1 has to come, because there is no clean closure. So 0 after 1 0 1 cannot be there, so we cannot use this. If we use 0 star for this, okay, 2 zeros can come, but then the 1 will not be generated next. So this string cannot be generated from the regular expression, but W does not belong to the. Here the thing is, actually language of regular is a subset of language of M. That is why we cannot generate these kind of strings, reverse strings. Anyway, so this is also false and this is true. We'll see why this is true analytically. You can check it out, like 0 star. What does 0 star means? You can check out in the machine only, that is will be very visible. What is 0 star? 0 star is any number of zeros. It is still in A. Then 1, it is in B. All right. Then 0 plus 1 0 star 1 whole star. So either you take 0, which is already in B, then 1 0 star 1 followed by any number of zeros is still in A, then 1 coming back to B. So in both of the cases it is already in B and there is a star. Read this any number of times and it will be accepted. So logically also this is true. Answer is A. Okay. Alright. Moving to the next one. Let M be a 5-state NFA with epsilon transitions shown in the diagram below. Which one of the following regular expressions represents the language accepted by M? Alright, let's see. Okay, as usual I can see the few things. Okay, first talking about this one, D. 0 1 1 whole star. Can you generate? First let's see, is null string accepted in this NFA? For sure, this is starting state. Null string goes to 2. 2 is final state. Okay, so null string will be accepted. Can you generate null string from this part? No. Can you generate, because 0 has to be there. Can you generate null string from this part? No, because 1 has to be there. Can you generate null string from this part? No, because 0 has to be there. What is A plus means? A plus means A to the power M, where M greater than equals to 1. At least one instance of A has to be there. Hence, at least one instance of 0 has to be there. So null string cannot be generated from this one. This is wrong. This is wrong regular expression. Okay. Okay. Then just one more simple intuition. Is 0 accepted in this NFA? That is the first thing that strikes me here. So 0 0 star. So is 0 accepted? Starting from what? In null string we go to 2. In using 0 we go to 3. Using null string we go to 5. So 0 is accepted. But here in A you cannot generate 0, because a 0 has to be followed by another 0. No other way to create 0 is there, right? So a 0 has to be followed by another 0. So single 0, this string W equals to 0. This string will not be accepted by A. will not be accepted by C also. Here also, whenever there is a 0 is followed by. So these two cannot generate. Answer is B is the right answer. Now let's see if it is actually logically true. So what is okay, so let's check it out carefully. What is 0 star? So a single 0 is accepted. Now what about 2 zeros? So we go to 2, then with 1 0 we go to 3, then with 2 0 we go to 2, final state, accepted. With 3 zeros we go to 3 and go to 5, accepted. With 4 zeros, from 3 we go to 2. So 2 access all the even number of zeros, and 3 is ending state for all the odd number of zeros, but there is epsilon transition, so we move to 5 and get accepted. So all number of zeros will be accepted. So 0 star is true. Then coming to the next part, this part says 1. So from 1 we take epsilon transition to 4, using 1 we go to 5, it is accepted. Then 0 0 0 whole star, so this is odd number of zeros, right? 0 0 whole star means even number of zeros, and 0 adding means odd number of zeros. So either from what is happening from odd number of zeros, we already have for odd number of zeros. For 1 also we will enter in state 5, so this is accepted. Then 1 1 whole star, so from 5 you cannot go to 3, but you can go to 4 and come back to 5, go to 4, come back to 5. So this is 1 1, so you can do any number of 1 1 from 5. So this is accepted, and put any number of 1 1s, this is also accepted. So logically this is true, B is the right answer. I hope you understood that. Okay, moving to the next question. Consider a context free grammar G with the following 3 rules: S to S AS. Okay, so rules are S to AS, S to AS BS. See here, A B C are terminals and S is non-terminal. Okay, NA W, NBW, NCW denote the number of times A, B and C occur in W respectively. Which one of the following statements is or are true? Alright, let's see. So S goes to AS BS. Okay, so from AS BS what can we do? We can replace all the S's with C. So it will be something like AC BC, or we can replace this AS BS and BS, then we can replace with C AAC BC BC, or we can keep continuing this again and again. Now what is the number of B and C here? See, I am not considering S to AS rule, because in no way it is going to I am checking for rules C and D first of all, which is comprising of NC and NB, NC and NB. Now in S to AS, this rule in no way it is going to contribute in number of S or number of A or number of C, right? It is only increasing the number of A's, because S to AS, then to AAS, AAAS, it will only increase the number of A's, no contribution to BC. So we are not considering it, and also we are just considering these two. So increasing the non-terminals or replace it with C at any point. Okay. Okay. So AAC BC BC. So in this number of NB is basically 1, NC is basically 2. Here NB is basically 2, NC is basically 3. It is, and if we replace like this one now, so AAS BS and AS sorry, there will be a B first, B AS BS. Replace this AAC BC BAC BC. Number of B is 3, number of C is 1 2 3 4. Always number of C is plus 1, right? Plus 1 plus 1 plus 1. Why this is happening? So for now we can see, from example, this is going to be true. Now let's see why this is happening actually. The logic behind this. We see the real-time demo, we see the examples that yeah, this is happening, this is true. This is how scientific research goes on, right? We get the data, we do the experiments, we get the data for some amount. Of course, we cannot get all the data from the universe. Okay, we run experiments, whatever experiments we run, there is finite amount of information we can get from it, and we try to understand the pattern. So we understood the pattern, it is going to be plus 1. Now let's try to run the theory behind it. What is basically A in ASBS? Number of S is 2, number of B is 1. Now when we replace one s, suppose this is, we are replacing. How the replace basically happens? So first we cut this off, so a b s, then we add this whole thing is b s b s. Okay, so first we cut off the s. So when you cut off the s, the number of s is decreasing. So now both of them are 1 1. Now we are adding as bs. What does as bs mean? 2s 1b, 2s 1b. So it is now 3 and 2. Okay, so why we are counting s? Number of s and number of c is same. At some point you will replace the s to c. So for one s, for one c. So c and s's count will be same. Forget about c. Let's count s. That is why. Okay. Okay. So number 3 and 2. Then in again some other step you will cut this off. It will be 2 2 plus 2 plus 1. So always when we add as bs, for 2s 1b is coming. That is why there is one extra s, and for that s one extra c is also coming. There is always be an extra s and an extra c will come. So definitely number of c will be 1 more than number of d. So if it is 1 more, then for sure into 2 is false. We have already seen 3 for example, that for number of b is 3, number of 4 is 4, number of c is 4. So it is definitely not into 2. This is also false. This statement is also false. Okay, now compare these two. Alright, so for any instance we have seen that here a s b s. So here let's ac make it ac bc. So number of a is 1, number of c is 2. Then let's make it a s b s b s. So it will be a c b c b c. Number of a is 2, number of c equals to 3. So it is also plus 1. What if we use the ASBS rule? What if we use the ASBS rule? So for this now we can see that NA is greater than NC minus 2. Here also NA is greater. So number of A and number of B are same in this rule. So whatever number of time we use this rule, A and B's count will be same. So if this is true, that number of C equals to number of B plus 1, so number of B equals to number of C minus 1, right? And number of B's count, number of A's count is same in this rule. So NA equals to NC minus 1, hence NA greater than NC minus 2. NC minus 1 के equal है, A is equal to NC minus 1, so NC minus 2 से definitely बड़ा होगा. So this is true, but till we use this rule. What happens when we stop using, we add the AS-BS rule? So it will be, suppose this AS we are replacing, so AS, BS, BS. Okay, so then, so we replace it A, C, B, C, B, C. So number of A equals to 3, number of C equals to 3. So it was first, it was a number of A equals to 2, number of C equals to 3. Now it is 3, 3. So number of A is always increasing. This is what this rule does. It is always increasing. So now we have seen that why, since till we use this S equals to AS-BS rule, number of A will be greater than equals to number of C minus 2. This is true. If we add the S to AS-BS rule, number of A will increase even more. There is no way of decreasing number of A. It will be increase even more. So it will be more greater than this. It will always be greater. Okay. So this is true. This is coming true. And number of A and number of B, oh, this is very easy. Let's just consider this one. I hope you understood that. This was a bit complicated to comprehend. I hope you understood. Otherwise, just rewind this video and you will understand why this is happening. And from this, we replace with C, AC, BC. So number of A and number of B are same. And here it is saying greater than. Greater than is not true. It is true for some case, but it may not be true for all the instances. This is false. Answer is B and C. Okay. I hope you got that. Okay. Moving to the last one. Actually, the questions in set 2 I think were a bit, I won't say hard, but a bit more tricky and challenging. Actually, I love to solve those problems. So, in set 1 the questions were more, I believe it was more or easy, easy to solve, easy to comprehend or interpret. But in set 2 some of the problems were a bit, this problem is specifically talking, this problem is very, very, I won't say challenging, but a nice question actually. So TOC problems were specifically good in set 2, the afternoon session. Okay, so L1 be the language represented by the regular expression this, and L2 be the language W belongs to a plus b whole star, where mod w less than equals to 4. Let's consider what is it. W is a string on a plus b whole star. So all the strings combining a and b with the mod w less than equals to 4. So of length less than equals to 4. All the strings of a and b of length less than equals to 4, where mod w denotes the length of string. Okay. Number of strings in L2 which are also in L1. Number of strings in L2 basically means all the strings of AB which are less than equals to 4 length are also in L1. So all the strings that can be generated from this regular expression and has less than equals to 4 length. That is simple. So let's analyze the regular expression. Okay. So okay. So it has two parts. First, let's talk about this part. A b whole star, a b whole star. Okay. If we interpret this one, so what is the strings that can be generated? What is the one length string? There is no one length string, because for 1a has to follow with it. Okay. So there cannot be any one length string. What is the two length strings? A is the only two length string. What are the three length strings that can be generated from this one? The three length strings are A, B, A, B. Okay, these two A's has to be there. So to make it three characters or three length, either we take one B from this or we take one B from this. So in two of the cases we took one B's. And what is the four length strings? The four length strings we do not need, because to make a string W of length 4, if we take 4 from this one, then we cannot take any instance from this one, but that is not possible, because this A has no clean closure. This A always has to be in the strings generated. So if this A has to be in the generated strings, we can only take up to 3 letters from the right side, because at least one has to come from this. Okay. Okay. Now let's then check it out. What is the okay? I won't expand this much. I will just now generate the strings. Okay. So B star A, B star. Now what is the four letter strings that come from here? So let's consider this section, that we are generating all the 4 letter strings from the left, this section. What will be the case? So it can be B, 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 A. So we take 3 B's from this one and no from the right one. Then we take 2 B's from this one, 1 from the right. Then 1 B from left, 2 from the right, and then all from the right. These 4 strings can be generated, right? Okay. So there are some other 4 length strings that also can be generated. Okay. So using this section, how? So we take the 3 letter strings from this one and add and we have already have the one A from the left. So we take the 3 letter strings from this section. So A B A and A B A, B, right? A B. So we append one A to the left side. All right. So is this all the 4 letter strings that can be generated from this regular expression? No, exactly. We forgot to consider the 2 letter strings. So A is there. So for this case, we have to generate 2 letters from the left. How can 2 letters from the left be generated? So with the A, we can take this B or this B. So BA or AB. So if we take BA, AA append, or AB, AA append. Okay. So let's length count. Let's keep a count. For 4 letter, we have 8 strings. Now for 3 letter, for 2 letter, for 1 length. Okay. Okay. For 0 length cannot be there, because as I said, this A has to be there. So no strings of 0 length. Null string will not be there. Okay. So now 3 length. For 3 length, what we can do from the left, we can generate for sure BBA, BAB, B or A, B, B, right? Using the right. Can we take the 3 letters solely generated from the right? No, we cannot, because with this, the A has to be append from this section, right? This A has to always be there. So appending that, it will be 4 letter. So no point of taking that. We can take only the 2 letter string from the right section. So if we take this AA, in how many ways we can append the left this A? Just one. So A. Okay. Okay, so it is 4. Okay, so now I will erase this, and I hope you are noting this down. If you want, you have to keep a good note. Okay, for 2 letter it is fairly simple. So from the left section we can generate BA or AV, and from the right section we cannot generate, because this we cannot take A. With this again A has to append, so we cannot generate. For 1 letter from the right we cannot generate anything, from the left we can generate A. So it will be 2, it will be 1. Total 8 plus 4, 12 plus 2, 14 plus 1, 15. Answer is 15. Okay, I hope you got that. These were the questions, very interesting questions I feel. And again, you guys can join our Telegram group, WhatsApp group, and you can check out our courses, premium content in our website. And till then, see you soon in our next session. Thank you.